Okay, so we went over the theory of higher order derivatives, velocity and acceleration. We're actually going to go over some examples for it now. Okay, so on the left, what we have are our definitions to help us make sense of everything. But the first thing I actually want to go over is higher order derivatives, or the derivative of a derivative. Okay, so we'll strictly go over higher order right now. So your first example in the book, they've given you a question. F at x is x divided by 1 plus x. And they determine the second derivative. So in other words, they're asking for double prime x when x is equal to 1. Or in other words, they're looking for f double prime 1. Okay. So what we need to do is we need to derive this function once. Then once we have the derivative in simplified form, we'll derive it again. Now this is the reason we would simplify something. If we don't simplify this derivative, then it's going to be very complex to do the second derivative of it. And that's why we started getting into simplifying them in the last chapter. So this question here, this is a quotient. So if you guys remember your quotient rule for derivatives, f prime x. Okay, let's call this g at x on top, and this will be h at x on the bottom. For our quotient rule, we find g prime x times h at x. So the derivative of the top of the fraction multiplied by the original of the bottom of the fraction, subtract the original g at x of the top of the fraction times the derivative of the bottom of the fraction. And of course, that's going to all be over our g at x, or the bottom of the fraction squared. Okay? Or sorry, not g at x, h at x. So there's our quotient rule. So we're going to apply that to this now. So derivative of x is just going to be the number 1. Okay. H at x is still 1 plus x. Subtract x, which is our original function on top. Derivative of the bottom, same thing, is still the number 1. And all of this is above 1 plus x now squared. We're going to simplify the top. This is going to give us 1 plus x minus x divided by 1 plus x squared. And if you notice, our x's created 0. So we're left with 1 over 1 plus x squared. Okay? But that's just f prime x. I simplified it. Now remember, like I said, technically this is f prime x. But then to find the derivative of that would have been much more complex. So we simplified it to get to here at the bottom. Our yellow part, we'll call it. And then from there, I'm going to find the second derivative. Okay? So the second derivative. Well, this again is a quotient, and we can solve it using quotient, or I can turn this into a chain or exponent of a function. And actually, I'm going to solve it that way, just because I think it'll be a little quicker. So I'm going to change this into 1 plus, that's not a plus, 1 plus x to the power of negative 2. So when we go to derive that, negative 2 comes down here. We have 1 plus x inside. We subtract negative 2 by 1. We're left with negative 3. And then we multiply by what was inside the derivative. So inside the brackets, we derive it. Well, that's just going to give us the number 1 again. So we're going to end up with negative 2 divided by 1 plus 3 cubed. Okay? All we did is bring the negative cube function down. Now the question actually asked us, though, to find the second derivative when x is 1. So we're now going to plug that into the equation. 1 plus 1 cubed. 2 cubed is going to be 8, so we'll have negative 2 over 8, which will give us negative 1/4. Okay? So what we've just done there is we've found the second derivative of something. We derived it, simplified, and then derived again. And then we also plugged in a value for it. They asked us to find the second derivative when x was equal to 1. and we plugged that into the second derivative function, we found we got -1/4. So that would be higher order derivatives, greater than 1.